8th graders lesson 4.5 is about compound inequalities, okay? So we've said inequalities are two sides that are not necessarily equal to each other. A compound inequality combines two expressions. So it might combine two things about the letter x, the variable x. X is greater than or equal to 5, and x is less than or equal to 7.
It's 6.
Okay, not necessarily. Could be an infinite number.
Could be around 6.
Because how many numbers are there between 5 and 7?
A lot.
An infinite number. Yeah.
Until 6.9.
No, it's still an infinite number. Because you've got 6.91, 6.92.
Well, it's not.
And then in between 6.91 and 6.92.
Between 6 and 7. There's not an infinite
Dylan,
amount.
don't interrupt me.
Okay.
Do you understand that there's an infinite number of numbers in between every number? Isn't there? Dylan.
Break it down.
Right?
Break it down.
So, the only way that you can express that is with an inequality, with a graph that combines these. And this then, this area between 5 and 7 is called the domain. It's the possible answers to that inequality, to that compound inequality. Okay? So, for this, we use a solid dot on both sides and an arrow that goes between them, or a shaded region that goes between them. Okay? If it is just less than or greater than, then you would use an open dot, of course, right? How would we combine these into one statement? How could you write this so that instead of having two different statements, you've got one statement? Do you see that up there?
Like that.
Can you read that?
5 is less than or equal to x, but x is less than or equal to 7.
Yes. Combining this, you start with the lower number. Look here, Bailey. Are you copying this?
Really?
Looks like you're just doodling.
Okay.
Copy the notes, okay? Now look at this. When you're writing a compound inequality, Bailey, you start with the number, that's the lowest number, 5, and you could say that that 5 is less than or equal to the shaded area. And it's we use this, it's a solid dot, so you have to use the less than or equal to sign. And then the shaded area is the x. And then the number to the right of that is the number that's greater than or equal to x. So the numbers are on each side, x is in between, and the numbers go between, okay?
So the domain equals x.
So the domain is the shaded area. The domain is the shaded area, the area for x, yep. Let's combine these. X is greater than or equal to -3. So you would mark -3 on the number line and shade x to the right. And x is less than 8. So you mark 8 on the number line, mark it with an open dot, and then shade to the left. And when you combine those, you have -3 is less than or equal to x, which is less than 8. Okay? And that's how you combine that statement. Question on this one, Dylan?
No, the one above it actually.
This one? The first one?
For 5 it's above the line, and for 7 it's below the line. Are you supposed to put it above or below the line, or have one above?
No, I did that just so that you could see
It was just
that arrow better.
lines.
Yeah.
Okay.
Yep. It doesn't matter. This whole area is shaded, and so rather than blotting it all out, I just put one above and one below, and then it's combined, you can see over here, okay? And that way it's just more clear when you look at it. That's how I want you to do your answers, is make them clear to look at, all right? So whether you shade above the line or below the line a little bit, just make sure that it's clear when you look at it. Now, here's one that you'd have to say or for, okay? Because x can't be both at the same time. So, for example, x is less than -3. So that would be open dot at -3. Bailey?
Yes, I'm listening.
No, are you writing?
Yes, I'm writing.
You're writing this down? It looks like you're working on your picture again. X is less than 3. Or x is greater than 7. Okay? So in this case, we'd have to say that -3 is greater than x, because x is to the left of -3. Or x is greater than 7. And that's how you combine those. Okay? So what you're going to be doing today is practicing reading and writing these compound inequalities. For example, in real situations, we have example 1 in your book. All real numbers that are between -4 and 6. All real numbers between -4 and 6. When you are doing these questions, you draw a number line and mark where 0 is. Put the numbers on that are given to you. So you're given -4 and 6. This is number 1 in your book. Okay? Now, if it's all real numbers, it means that there's only it's all the numbers possible in between here, but it's between, not equal to. So we use an open dot if it doesn't include those, Dylan? Yeah, an open dot at -4, open dot at 6, and then, excuse me, shade in between. Okay? All real numbers between -4 and 6. Okay? Number 2, all real numbers that are at least 2 and at most 9. So again, draw the number line. In this case, both are positives. So 2 and 9, mark those. All real numbers that are at least 2. So is 2 at least 2?
Yes.
Is that included? So we draw a solid dot. And at most 9. So would we mark 9 as possible? Would we use a solid dot or open dot?
Can't see.
At most 9.
Open up.
Is 9 possible? So then we have to use a solid dot.
Could you go to like 9.9999999? Where is that?
No, at most 9. That means it stops at 9.
Oh, okay.
Not 9 point something, but 9 or less. Okay? So how would you write that inequality then as a compound inequality? How would you write this one first? Let's go back to that. How could you say that as a compound inequality? Start with the lowest number. -4 is here, this is x, okay? So -4 is less than
Or equal to.
or equal to?
No, just less than.
Just less than. Negative 4 is less than x, which is less than
6.
6. Right? And in this one,
2.
start with 2.
X is in the middle.
Remember that we're telling you this is x, the shaded part is x.
X is
So 2 is
less than or greater than, or
less than or equal to x,
You put X in the middle.
which is
Less than or equal to.
less than or equal to 9. Yep. Good.
So, in the domain, one of those numbers between 2 and 9 is x.
Is the x, yes.
How?
Or it could be, x could be multiple things. For example, if you see these signs where it says speed limit, a speed limit sign where it says 75, and then it'll say a minimum 40. Why would they want a minimum on a highway?
Because
you
if
don't go like 2 miles an hour and back people up.
Or are you gonna say?
I was gonna say that if you go slow enough, you're gonna get like really low everything.
Yeah, when there's a great difference in speed,
So you have one guy.
then the time it takes for you to run into something that's stopped when you're going 75 miles an hour is very small compared to if they're also moving,
75.
right? Or at least 40 or 45 or 50. So how would you graph this then? How would you graph a speed limit
40.
of 75 and a minimum of 40?
Put 40 down there, or actually put 0 there, and put 40. And then you put 75 closer to the end. Yeah. Very accurate graph.
Yep.
If you have 40 miles per hour in the span of like.
But I put a break right here, which means that it's not a true represent. Right, it's not to scale. Yeah. Okay. So then what?
40 is,
Can you drive 40?
yes.
Okay. So we need to mark this with a.
What? 40 is
What
less,
kind of
Put
dot?
X in the middle there.
40 is less than or equal to x.
So what kind of dot do we need?
Solid.
Solid dot. 40 is less than or equal to x
X. Or,
if x equals speed, right?
yeah. But
And
X is less than or equal to 75.
x has. So you can drive 75? Any questions? That's how compounds inequalities are used
That's
in
all right.
real situations, okay? All right, your assignment then is to, let's see. All right, so what we're gonna do with this, since this is pretty basic stuff, what we're gonna do with this is actually use these to solve some inequalities, okay? So, when you're solving a compound inequality, you're going to solve each one separately. Let's look at this example. Number 5. 3 is less than j plus 2,
What page are we looking at?
which is less than 7. Okay? Now, I want you to look at it in two ways. First, look at this one. 3 is less than j plus 2. Can you solve that for j?
You put, like define J in the middle and then add 2 miles.
Yeah, how would you, if you just looked at this part,
Okay, you have 30 miles and 70 miles.
Now solve it for j. We have to get rid of the 2. So add -2, add -2, and
What about the
One.
negative 2 on 7?
1 is less than
J.
j.
Or J's greater than 1.
Okay?
What about 7?
Now, look at this same one and solve this.
Again, add -2.
Again, add -2,
5.
and j is less than
5.
5. Okay?
Oh,
That's
so
how you
then-
solve a compound inequality. You solve these two separately.
So you pretty much keep the 2 for both of them?
Why not just add negative 2 on all of them? Just make it.
So, let me graph this. 0, 1, 5. Open dot. 1 is less than j, so j is in between. And j is less than 5. So that's the graph for it. Okay?
What's the assignment?
Your assignment is 6 through,
7.
no, let's go 6 through 10.
That's not bad.
Okay, doing this. 6 through 10, okay? Any questions?